electronics manufacturing in the country. Government of India has been bringing many schemes, many initiatives to promote various sectors. Electric vehicle segment is one of them, and electronics also. We are seeing multiple schemes which are being launched to enhance the production and the manufacturing in the country. So I'll just cover up some part of the schemes which have been the initiatives which of the Government of India brought in specifically for electronic sector, as well as for which are relevant for electric vehicle segment. And I'm sure because there are industry members available in the forum, we would probably be getting recommendations from the industry as to what additional efforts government needs to put to further further promote this segment of the electronics. So Indian automobile industry is a dynamic industry and has grown to contribute in a big way to the Indian economy through manufacturing, through exports, employment, and investment. Be it be it two-wheeler manufacturing, be it four-wheeler manufacturing, be it the tractor manufacturing. It is India stands in top 4 positions in any of the segment. India is the 4th largest market for vehicles, and it is expected to be 3rd largest in terms of volume by 2026. Domestic automobile production increased from at around 2.36 CAGR in last 4 or 5 years, and automobile sector has been generating a lot of employment in the country. The electronic and this automobile sector, the share in global R&D, India also holds around 40% share in the global R&D, and it is also having consistent FDI inflows. This particular sector, it is around 5.1% of the total FDI inflows during last 20 years. Speaking about auto components sector, the growing presence of global automobile OEMs in the Indian manufacturing landscape has significantly increased the localization of their components in the country. India has become the preferred designing and manufacturing base for most global auto OEMs for local sourcing and exports. The auto components industry also expanded with a CAGR of around 6% during last 4 or 5 years. And this subsector, the auto components itself, contributes around 2.3% to the national GDP, and is also contributes to the a huge employment around 5 million people in this by this sector. India auto component industry is expected to become around 3rd largest in the world by 2025. Coming to the electronics sector, we have been living in an exciting times as far as electronic sector goes. The domestic production in electronics items has increased substantially from around 1.9 lakh crore in 1415 to around 5.3 lakh crore in 1920, with a CAGR of around 23%. India's share in global electronics manufacturing has also grown from 1.3% in 2012 to 3.6% in 2019. India has also, of late, started exporting significantly, and the exports are also, shown 34% growth in year-on-year, in 2019-20 as compared to 18-19. We are actually, these manufacturing is this particular segment, electronic segment, is led by mobile phones, network equipments, chargers, PCBAs are the major items, which are being manufactured. And electronics industry also, is a major provider of the employment, and the mobile manufacturing, electronics manufacturing itself is around, provides around 7 lakh employments as per industry estimates. Ministry of Electronics and IT came out with a national policy on electronics to position India as a global hub for electronic system design and manufacturing by encouraging and driving capabilities in the country for developing core components, including chipsets, and creating an enabling environment for the industry to compete globally. Under the umbrella of National Policy on Electronics, MIT had launched various schemes during last year, during the lockdown. It was basically 23rd of March, the lockdown was announced, and MIT launched around 3 schemes on 1st of April. The first one was production-linked incentive scheme for large-scale electronics manufacturing, which, in addition to mobile phone manufacturing, included specified electronic components, including ATMP, which is a critical part, which is an important part of manufacturing the ICs. Another scheme was scheme for promotion of manufacturing of electronic components and semiconductors, in which MIT had offered, the government of India has offered around 25% incentive on capital expenditure for the identified list of electronic goods, which included electronic components, semiconductor display fabrication units, ADMP units, and specialized sub-assemblies and capital goods for manufacturing of aforesaid items. Another scheme which was launched on 1st of April 2020 was Electronics Manufacturing Cluster (EMC 2.0) scheme, which was providing support for creation of world-class infrastructure, along with common facilities and amenities, including ready-built factory sheds, plug-and-play facilities for attracting major global electronics manufacturers and their supply chain to set up units in the country. The electronic sector is particularly, 100% FDIs is allowed, and we are seeing consistent FDI inflows in this sector also. Other than these schemes, which were launched during COVID lockdown, we have been working closely with the academia as well as industry to not only, these are the, short-term reliefs for the industry to, to attract the global investments in the country. MIT has been working closely with academia to make it sustainable in the long term, and has been working with academia and industry partners to set up various center of excellences for this sector. Few such center of excellences are Large Area Flexible Electronics, National Center of Excellence for Large Area Flexible Electronics at IIT Kanpur. National Center of Excellence for Next Generation AMOLED displays, which are also quite relevant for automotive segment and EVs. This has been set up at IIT Madras, and also establishment of gallium nitride ecosystem enabling center and incubator at Indian Institute of Science, Bangalore. So coming to basically when we talk about electric vehicles, government has been taking various initiatives to promote electric vehicles, be it promotion, attracting the investments for manufacturing, or be it the driving the demand in the country. Few such examples like a production-linked incentive scheme, which has been allotted around 18,000 crore rupees has been allotted by cabinet for advanced chemistry cell batteries and automotive components, and national mobility of electric mobility mission, and FAME 2 scheme all of us are aware of from Department of Heavy Industries, and national mission of transformative mobility and battery storage. As in any other electronic product, ICs would play a major role in developing the EV markets in India, and ICs is seen as a product which would have a tremendous growth in the tremendous demand in the Indian EV sector. Government is government is aware of the importance of semiconductor fabs and the IC manufacturing ecosystem required for the development of the sustainable electronics manufacturing in the country. Ministry of Electronics and IT, under the guidance of Empowered Committee, had come up with expression of interest, request for expression of interest, inviting interest from the global fab companies, global IDMs, as to understand what are their what would it take for them to come to India and set up their manufacturing units in India. What are their expectations from the government? So we had launched expression of interest around 15th of December last year, and for last 2.5 months, we have been interacting with around 25 to 30 companies of this domain to generate their interest, and to understand their interest for Indian ecosystem. And we are quite hopeful that we are going to receive a handsome number of expression of interest in case of we have basically defined 3 categories. One was for traditional silicon chip manufacturing, and another one was for compound semiconductors, which is especially important for electric vehicles. When we talk about compound semiconductors, GaN-based, silicon carbide-based, semiconductors, which are especially being used in high power applications and RF applications. So we have seen good number of companies showing interest in case of compound semiconductors, and a couple of interests which are shown in case of traditional silicon as well. So we are hopeful that from 2 years down the line, we'll be having a good ecosystem where sufficient number of semiconductor fab companies will be present in India, be it traditional silicon or be it compound semiconductors. So since from EV components perspective, I look these two, the battery, which is around half of the cost of electric vehicles as on date, and the importance of availability of integrated circuits. So since NITI Aayog has been spearheading the efforts in case of advanced chemistry cell batteries in consultation with DPIIT and Ministry of New and Renewable Resources, MIT is spearheading for semiconductor ICs, and we are hopeful that this ecosystem will evolve from 2 years down the line. I would like to stop at this point and would love to listen the perspective of the industry regarding this. Thank you.
Thank you, sir. Thank you for your opening remarks and valuable insight. I would now like to introduce our keynote speaker for the day, Dr. K. Balasubramanian, Director, Non-Ferrous Materials Technology Development Center. Dr. Disciplinary Technology at Hyderabad, India. Serving as its director over 2 decades, he created centers of excellence, namely COE for Advanced Materials and Processes, I welcome you, Bala sir. Over.
We can't hear you.
Yeah,
Okay.
sir.
Thank you. Got it. Fine. So I won't take much time, except to say where we are and where we should go. And good afternoon to all of you, and thanks for the invite. And we are at the threshold or at the at the springboard of takeoff in electronics and power electronics in a big way. Compared to all other missions like space or atomic energy or defense or even agriculture, we did not create an electronics mission in 1970s, and we are paying the price for it in terms of our, I would say, call it as backwardness in terms of component systems and whatnot, and solutions. We could have been an equivalent of pharma in this sector, but in electronics things change fast, and therefore we can even catch up on some of them if we get our act together right. Coming to today's theme of quality and standards and other related matters, what we find is that the concept of quality, which is for reliability and reliability, systems level reliability, is kind of very well understood in many sectors, particularly space or defense or any of those big system players. But when it comes to a consumer product or something that is used every day, the numbers are bigger, and so we have to handle large number of components as well as large number of systems. So I would say that, look, we can break this up into 4 levels, and it finally boils down to testing. Test, and can we test more? Can we test fast? And can we get a go, no go on many of the things? So if I just forget about the standards for a minute and say that the tests eventually give you the standards, we find that the tests fall in 4 levels. The first level is the developmental phase, where we are developing systems or components or whatever. So what we are asking for is a very fast feedback, so that the developer, whosoever is on a breadboard or whatever it is, gets a feedback faster to tune. It could be an embedded algorithm, or it could be there is software in loop, or it's actually choosing the rating of the components. And people who have developed controllers or BMS or any of these EV components would know that they would have fried a lot of breadboards and things, and the faster you burn and fry and come to the solution quickly, the better you are. So a set of testing equipments and testing procedures are around that developmental phase. The next place where they become important and slightly more critical is what we call as in-process QC. Like when you have a number of process steps, we need a go, no go between the process steps so that we don't get more rejects in the end and where a lot of value has already been added. So if I may give an example, I was talking to one of the German manufacturers of power electronic equipments, and what they said was the IGBTs that they were procuring as their inputs, components. They were taking the rating that was given in the data sheet, and they were using it as it is in the design, and they found out that the final product reliability was going down, and they finally traced it to 10% tolerance that was there in the rating, and therefore it's like you buy 1,000 of them, you find that there is a Gaussian curve, and so they started testing each one of them and started putting it in a very, very close band. I give you another example in EV. If you're taking cells in a battery for a battery pack manufacture, the cells have to be within plus minus 0.1 volt. Otherwise, the cells will start discharging amongst themselves, and you get a totally different situation. Anybody who has developed a bearing would know that the ball bearing diameters have to be so close, or they have to be matched opposite to each other, so that you get final runout tolerance. So in other words, the in-process QC from raw material to the product, it's another set of QC parameters that we do, and you just cannot simply take the ratings that is sitting on the data sheet and then not know the tolerances are being wide and then start working on it. I mean, these are all our lived experience, so it's not just a theory that I'm talking about. The third level of QC comes in what do we call as the product performance, which you're going to certify. You're certifying your product. Therefore, you have to have either a statistical or this testing. And here we find that the cost is quite high, and it all depends on, in EV sector, it all depends on how much you want to test. You want to test both software in loop and hardware in loop testing becomes important. For example, if you're doing a controller, motor, battery, these three major components, if battery includes a BMS, then what we find is that, how do you test 100% of the motors before it goes to the vehicle on a motor test bed? Your controller, particularly the algorithm, the fine tuning of the algorithm that was done in the first phase, developmental phase, and when it is integrated to the product between the motor and the battery, it has to pass. And therefore, what you are going to eventually develop is a lot of simulators. You have to have a lot of simulators that into which the critical components are put in, and it becomes a loop. Hardware in loop and software in loop testing comes in a big way. And that's where we find that a lot of apparatus and test bed developments are necessary, and we have to do that as well as a co-product development. And last but not the least, which I think Dr. Deshpande might talk more and better, regulatory testing, which is different from development and in-product QC. There are standard cycles and standard parameters that they would test, which might be even different from a duty cycle or a load cycle that we would have taken in the developmental phase. But there is a guarantee that you have to give for the customer, which comes on the regulatory testing level. So you have these four levels: developmental phase, the in-process, that is production, manufacturing, process, product phase, and the third is the product performance phase, where hardware in loop and software in loop for performance becomes critical, and finally the regulatory testing. Now, let me conclude this short presentation with just a couple of points. When I started these electric vehicle things way back, nearly a decade ago, when we were alone and nobody was around to talk about these things, I used to introduce the system level thinking to people in EV in a very simple way. They said that, look, if you have done 12th standard math, physics, chemistry, you should be able to do that. So motor is all physics, a lot of electromagnetics. If you can rotate a vector in your head and understand the electromagnetic flux, you design a motor very well. And the controller is all math. It's fully algorithm. The components are there, yes. The rating, the hardware components are there, starting from your MOSFET, IGBTs to wideband wide bandgap semiconductors like silicon carbide. But finally, it is the software that is 60% of the cost. In fact, the software won't be given to you. It is burnt in, it's flashed in, and therefore, we have to have our own developmental software, our own software in India. Otherwise, every controller is tuned to the motor for the highest efficiency in terms of parameters. And battery is chemistry. It's all chemistry. Finally, it's all chemistry. So it's math, physics, chemistry is the play here, and the appreciation of at a system level thinking is required, both from development to production. And here I would tell you, like, what we assume as simple is not so simple. I give you a very small example. Stator winding. Everybody goes and winds the copper wire, in the stator, which is the flux creating part. The point is that we had the biggest QC problems only in that, because it is still manual. We can't. It creates a lot of employment. In fact, one of the biggest employment generation point is the stator winding. So if you look at that, and okay, if it is 10,000 numbers or more, you can try to develop a machine which is nothing but a hydraulic machine pushing wires inside. But what we have learned is that what is done manually comes out right, unless otherwise the person makes a very serious mistake. But the automated machines have nearly 40% rejections because something rubs against other, insulation goes off. You don't find it, you find it very, very late. So now this is where the difference between Germany and India comes. The Germans go in for a machines. We can create a huge employment, in just this one process step. Not to mention the PCB board manufacturer, where pick and place machines, etc., are all very good. QC is done online as it is manufactured, so the mistakes don't happen there. So that's the biggest advancement that has come, which I would call it as in-process QC. So these are all in-process QC examples. And finally, I'll close my address with a very, very small this thing, that today artificial intelligence, or I would say machine learning, more specifically machine learning, allows you, as you're doing a development, you're also collecting a lot of data, and therefore you don't want to lose the data at any point, as be it in process, manufacture to product. So you have 100% traceability to the component. Now, because you have 100% traceability to the component, particularly the critical components, when the failure occurs, where it can be traced back. And then the AI, even machine learning, goes even to the level of behavioral identification, how a person drives, and what is a kind of driving behavior, and we can even map the duty cycle of that person versus vehicle very, very easily and start predicting. So to that level, yes, the data acquisition and the learning methodologies, which can easily be tracked to dumped to a cloud and tracked and done, happens. So this is the overall systems level thinking that I would like to present to people, that QC and testing is all over the place, from startup development till the final user behavior, and even when it comes to service or breakdown after it comes. So it's a continuous process, and this is where we have to play a bigger role in giving the reliability and not get into the jugaad solutions. Thank you.
Thank you, sir. Thank you for your valuable insights. I would like to introduce our moderator for today's session, Mr. S.A. Sundaresan, Vice President, and E-Mobility Solutions, Ashok Leyland Limited. Mr. Sundaresan has been an entrepreneur and a technology innovator, designing products and processes. A mechanical engineer by education, past experiences range on developing and business digitalization, system engineering controls, and digital twins. Currently, as a Vice President, Electric Vehicles and E-Mobility Solutions at Ashok Leyland, is responsible for developing new energy vehicles, their aggregates, and related solutions. Over from here. Thank you.
Thank you, Shruti. Good evening, everyone. It's a privilege and an honor for me to moderate this session. We have five very eminent panelists covering the entire spectrum. So we have representatives from electric vehicle OEMs, then Tier 1. We have people from standards and testing agencies, and finally we have a technocrat and an entrepreneur. So we are sure to listen to all shades of opinion and from different perspectives. And we already heard two excellent talks from Prashant Kumar and Dr. Balasubramanian. So I'm not going to spend too much time talking about my, whatever points I have. I will include them finally when we come to the summary session. Let me first then start with the OEM's perspective. I would like to welcome Mr. Nishant Arya, Chairman EV and Future Mobility, ACMA, and Executive Director JBM Group. To introduce Mr. Arya, he has led JBM to expand its key businesses as well as to transform it from an auto ancillary to various diverse domains and a name to reckon with in each of these industries. He has been actively leading R&D, engineering, diversification, international business, and new projects. His visionary leadership has been instrumental in planning various technical collaborations and joint ventures with renowned foreign companies, including buyouts. These include some key domains such as electric bus, EV charging infra, EV aggregates, engineering and design centers, renewable energy, artificial intelligence, etc. With this background, I would request Mr. Arya to address the following questions. So what exactly are the customers looking for when we go for electrification? And how can industry meet these requirements? So what do we need in terms of ecosystem, partnerships across industries, domains, and even geographies? And what role is the government playing? How does the recent budget fare in pushing electrification? And what more does the industry want from the government? Over to you, Mr. Arya.
Thanks for the Sandration. I'll definitely try and address all the points which you have mentioned here. So I have a short presentation. I'll just share that 1 second. Yeah, is my presentation visible?
Yes.
Yeah, okay, perfect. So very good afternoon to all. I think we have a great panel here, and Mr. Kumar and Dr. Bala have set the stage very well to clearly see that how EV will be playing a key role as we move on with the EV transition in the country, and what we really need to see and how things can transition from where we are today. So just to see that a global e-mobility outlook from my perspective, that how if we are having almost 30% EV transition from up to 2030.
We are not able to hear. Can you adjust your mic?
Hello, am I audible? Hello.
Yes, I am able to hear him.
Yes, sir. Yes, you're fine. You can go ahead.
Okay. So 2 million barrels of oil will be saving on a per day basis with the EV transition, and only 3 to 4% increase would be there in additional power. So I think that clearly demonstrates that how we as a country have this kind of an opportunity when we are moving into electric vehicles with zero emission. And the kind of number of EV models are getting launched, so the opportunity which any customer has to buy such products. And the charging time at the same time is reducing significantly here from 6 to 9 hours to as low as half an hour. We see could, as the technology is progressing in next 3 years. And definitely, whether we look at any kind of electric vehicles, how they would break even for different customers. But why actually we are talking about EV, I think that is very important for us to understand. So as a country, we are highly dependent. About 85% of our requirements we are importing, and that's a huge burden for us. And at the same time, India as a country where pollution is a huge challenge, transportation is the second largest contributor to the pollution issues which we have. So what do we need to do, and how can we really address this? And because of this, of the top 20 cities, 14 most polluted cities in the country are in India, where we have multiple challenges. There are closures. We have issues in the city, even the capital city of Delhi, with the Parali burning and many other such challenges which are there. So what can we really do and really see that how health and environment is really a focus. So for that, I have tried to capture that actually what are the different modes of sustainability we need to look at, and how can we take a complete perspective from generation to consumption, and at the same time what is the level of disruption it causes to our existing ways of transportation and the modus operandi which people are used to. So here we have given a clear perspective of CNG, biofuels, hybrids, fuel cells, and electric. So going from solar farms to energy generation to distribution and charging infrastructure, I think that is very important. And definitely we'll see that low emission and zero emission technologies, all of them will coexist. And EVs will be playing a very important role, but definitely there'll be a lot of hybridization and other things which will happen in the future as fuel cells come in and as other biofuels also start kicking in. So I think there'll be a space for all, and eventually all of them will be eating out into the diesel and the petrol market, which is there today. But why we are looking at electric today is clearly because the customers, they have certain set of expectations. I am taking an example of electric buses and public transportation here primarily, that how they are looking at the 3C1S as we call it. So clean, connected, and comfortable and safe environment, which is even affordable for them. How the noise levels are going down, the pollution levels are going down. Our import bills is reducing, and quality of life is really changing. And today, what we look at as a need, that is converted into a choice which these people make when they're using these systems. Because even if we've seen FAME, the highest allocation has been given to public transportation, because that is where we are talking about the highest level of asset utilization as well as mass adoption of electric mobility to enhance the benefits multifold. So with all such kind of technologies, I think it's very important that how we are increasing our efficiency and how it is a real experience we are giving to the final users. I think that is what the customers are looking for, and definitely it's a luxury ride like experience with this, and they are really using this because they find very comfortable and it's the need of the hour. At the same time, what is important is that how are we giving them a right total cost of ownership. Even all of us understand that the upfront cost is high, so we look at the variable cost, we look at the fixed cost and the operating cost, and then we see that what is the total cost per kilometer in such kind of vehicles. And then we have to really understand that it's a combination of energy and mobility. So lightweighting is very important. We have the right powertrain configurations, how the system efficiency. I think Dr. Bala was referring to this in different ways, which is very essential. We're reducing the paralytic losses, and the road load data acquisition is being done in a proper manner, because India has a very big demographic and geographic pattern across different cities. So there is not a one for all kind of a solution. Every city, every location has a customized solution. And that is what would be enhancing the value proposition for the end customer, which we cannot play around with. Moving forward, we see that there are different parameters impacting electric mobility adoption, and as the mobility is moving forward. So these drivers are around battery, the pricing, lifespan, weight, efficiency. Then we talk about recycling, end of life, customer concerns around economic rational, as we just saw. They have range anxiety, how long the battery would run, will it drain out in the summer or not, what kind of vehicle performance, after sale support, the resale value, because there's no trend in the past, what kind of charging infrastructure will be available, how would it be available, what kind of charging will it do, how much time will it take, what are the standards and the norms. And definitely that, like the transition of BS4 to BS6 helps us to see that the parity is getting reduced, and the costs have increased on that front, and here it's the inverse relationship. So if I look at a holistic operating pattern, there are multiple things which need to be done. A lot of planning is required with what kind of charging facilities, investment planning, standards, where a lot of work is being done by BIS and many other bodies, by DHI, by Ministry of Power, and DPIIT, and Ministry of Commerce, Honorable Minister also declared that EV components are so important. And here, when we move on to the implementation side and operation maintenance side, I think it's a host of things. So it's a very integrated approach which is required for the whole operating ecosystem. How at bus stands, at terminals, things would operate. How the benchmarking can be done with global systems which are set up across the world. So multiple things to do. And simultaneously, we look at who are the key stakeholders in different forms and ways, from the demand assessment to charging to manpower planning, tariffs. They are giving subsidized tariffs. Different states are having their own EV policies. So between government, energy suppliers, and private operators, what's the real mix which drives this? And at the end of it, how the end customer is getting benefited, how we are able to create a complete life cycle of such kind of products is very essential. And as Mr. Naresh was saying, so the fulcrum for this EV penetration is the government. They have acted as a catalyst, and really starting from FAME 1 to now FAME 2, we are really seeing that how people have really got sensitized. There's that kind of awareness which is there in this. And until the end of next financial year, we are having a clear roadmap. And definitely, as we see that for all kinds of vehicles, there is a clear methodology how different states, how different categories of vehicles can be taken up, whether we talk about two-wheelers, three-wheelers, four-wheelers, strong hybrids, e-buses. And as you see, the largest distribution is an allocation of the public transportation, whether we look at e-buses or three-wheelers. And definitely that accounts for almost 70% of the whole allocation for the vehicle category. So that clearly shows that how mass adoption is the prime focus, and personal mobility will go second after this. Even in the budget, we have seen certain key elements around this, that the introduction of the vehicle scrappage scheme, about 18,000 crores allocation to buses, of 20,000 buses under PPP model, how the infrastructure allocation is tax exempted, the BCD and other custom duties have been reduced on certain key elements of the metal products or non-ferrous and ferrous. Then in certain areas, actually, it has been enhanced where they want to see the local industry can benefit from it. So that is very important to encourage the local industry to invest and really move forward. So I think that is essential. And just to add to this, on the PLI front also, the automotive industry has received a lion's share of about 75,000 crores, 57,000 crores for auto and auto components, and about 18,000 crores for batteries. So that gives a real boost that how India can become the global manufacturing base. How we at JVM look at it is actually not one part of it, but the whole ecosystem. So whether we talk about an OEM, key aggregates, and I'll talk more about this in detail as we move forward. So starting with key aggregates, because our prime focus is components and the opportunities on power electronics and other integrated circuits which can be offered. So we see that there are many areas actually, in battery packs. Is not only battery packs, but you're talking about BMS, thermal management, cells and modules, then your power management systems, wiring harnesses, DC-DC converters. So there are a lot of different technologies which are already being used in India, and there are companies doing it in the automotive sector, in the power sector, in the defense sector, in the railway sector, where a lot of high voltage applications are there, including electric motors we are using in different areas, different kind of controllers, propulsion systems, charging systems, which throw open a plethora of opportunities. And at ACMA also a lot of work is being done here. ACMA is the Auto Component Manufacturer Association, which is working on such kind of technologies and really working. And there's a separate pillar on electric vehicles where we are clearly seeing that we are engaging with different companies. So any concerns which are there could be taken up with ACMA as well. And then in FAME, we saw that there was clear PMP program which was laid out, and with clear timelines for each category. I think they have given a clear roadmap how companies should start producing locally, and we are not losing out like we lost out in case of solar in electric vehicles. And then I have just taken up couple of aggregates which are very important on the traction motor side, how technologies are really moving and the way they could move in the future, how SRM could become, or the in-wheel motor drive would become the basic standard in years to come, and how they really provide that kind of benefit. And we do not need to depend on permanent magnets actually all the time. And there could be other technologies, other elements which could be used here through our innovation, and the increase in scale would really make us self-sufficient. Similarly, On the battery chemistry, we talk about the energy density, we talk about the pack cost, then the life cycle, and that is different for each category, whether lithium ion or LTO or sulfur solid state batteries, how energy density is going up year on year, the number of cycles are increasing, and definitely we are seeing that with that we'll have the hockey stick approach, and as the parity is hit, definitely the government subsidies are acting as a good catalyst, but that is not the end of all. That is just the starting point to really for the industry to take off and really work on such technologies. Moving to charging infrastructure, I personally see that definitely there are different options on slow charging, fast charging, opportunity charging, and in today's day and age, I think it's very important that any kind of new technology you bring in, you reduce and minimize the disruption you have in any particular category. So I personally see that either opportunity charging or fast charging is the most preferred option in this particular space of buses to start with, because every city has depots and there are terminals in every city, and how you can reduce the downtime, enhance the uptime of these vehicles, and really see that how are you able to provide the latest technologies with which the buses can really have a very longer life. So just to explain that clearly in the charging technologies. So the autonomy, the weight of batteries, and the bus fleet, how the energy consumption is getting monitored, number of charging stations, fast or slow charging, infrastructure cost. So holistically, everything gets captured in total cost of ownership. That is what is most important. And total cost of ownership really decides the way that what kind of systems are important, because as we move forward in a charge, we have to look at the charging ecosystem. So in the charging ecosystem, whether it's the vehicle management system, the grid monitoring, energy generation, we have to have a very integrated approach, that how we are charging in off peak hours, which is in the afternoon and at night when we are doing such kind of things. And that is when the fuel prices, which is the power price in this case, is at the lowest as well. And definitely the availability is also much higher, so that also goes towards grid balancing in a way. So one has to clearly understand that how you're monitoring the vehicles remotely, and then able to really give a solution for large fleets today. So that is what is most essential, and with that a clear service management system has to be put in place. Talking about the ecosystem at a OEM level, I think what is important today for us is that how with such solutions, what I was sharing earlier, because large battery packs definitely do give a solution of charging at night only, but then that means less number of passengers, because all of us follow the gross vehicle weight GVW norms. And with fast charging, and if you're using the right kind of battery packs, we're able to optimize the size of the battery, as the prime purpose of the bus is to carry passengers and not batteries. And we are trying to see that how the current operating model of buses is also not getting disrupted. So that is our perspective, and that is how I see the market is moving. And that is the current trend in the global markets, emerging markets in Europe, in North America, where they are trying to see how they are doing opportunity charging or fast charging. So definitely we are committed to this with our products. And with every electric bus, we reduce about 350,000 liters of diesel and about 1,000 tons of CO2. Then the perspective is that how you integrate all these elements. I think that is very, very important. So we have this approach which we call well-to-wheel approach, and there we definitely try and see that the electric bus depot. So electric bus depot is not only electric buses. We have energy storage systems. How it's end-to-end green. So we're generating power from photovoltaics at the depot and in the surrounding locations, and how it can become self-sufficient. So from the oil well to the vehicle wheel. Otherwise, only electric vehicles would cater to tank to wheel, and the generation is not green in that case. So, with the well to wheel perspective, from solar energy or any other green energy to charging, to infrastructure, to vehicles, to the future system of energy storage, where the batteries which are used in the vehicles can be deployed in energy storage later on, can be taken up. Then, certain key enablers which are important for EV adoption today, which will change the whole paradigm. What we have seen in different parts of the world, how the government could look at zero emission zones, whether it's cities, airports, heritage sites, Taj Mahal, other shrines across the country. So where this could be set up, and definitely to preserve those, it's very important for us to see that we are reducing and cutting down on the pollution. Clear direction roadmap, what we have in terms of FAME 2, and now we have 1 year left, and what's there next definitely will give a fillip to a lot of investments coming in the country. Fiscal support with respect to TCO parity, I think that's very important. In every segment of electric vehicles, the TCO is different, the way it is utilized is different. And how, like we have PMP now, so with clear focus on supply chain development, how that can be incentivized, how companies want to invest and develop everything locally. I think one area which we have missed out on is how to incentivize the R&D, local development, because with so much of new development on the aggregate side, vehicle side, a lot of investment is going into R&D. How we as a country can really see that local R&D is being supported, and whether it's industry academia partnership, different government institutions like NFTDC and other institutions which are doing a lot of good work, how people can collaborate and they can be given that kind of boost that everything should be done locally. And simultaneously, a lot of skill development is required for learning, unlearning, and relearning what people are doing in these sectors. And such centers would be very essential. And I think for and foremost point from my side here is how power infrastructure is very important. Like we have the Udan scheme for really seeing how discoms and other setups in the country can be made very healthy, and they are able to support such kind of transition in the longer term. Some such kind of mandate where every state is providing power at prices which are promoting the EV sector, as well as providing the infrastructure, the connectivity, so that the penetration of EV in those cities can be really developed further. And these are certain initiatives which definitely can be taken up for making EV a success, clearly. So whether we expand the EV model availability, which I see a lot of new models getting launched, as I shared with you, the different R&D projects, demonstration projects for improving the competitiveness. How we are talking about financial incentives, but many non-financial incentives, seeing that how the other vehicles are getting disincentivized. There can be certain kind of mandates which can be put in place. Public fleet transition is, I think, a very important element. But simultaneously, whether it is schools, it is corporate fleets, they will be equally important. Different kind of grants and partnerships for releasing the charging network, how it can be developed. And we will be having all kinds of charging, whether it is office, charging at workplace, charging at home, charging in public places, charging in malls and hotels. I think all such kind of things are very essential. And last but not the least, all of this, how it is getting communicated to any common man, I think that is very important. Companies like us are very committed to this sector and definitely want to give it our clear perspective and the best shot. But what is that a common man can get, what kind of skills, what kind of education can be provided, and definitely seeing that each and every measure is giving a desired result, and how India as a country is becoming more self-reliant. And as we see from the PLI perspective, it is becoming a global manufacturing base which is not producing for India but for the world. I think that is going to be a game changer for us, and that is where we look at competitiveness. So we would not like to be cheap, but we would like to be competitive. For that competitiveness, technology will have to drive value. And how technology can drive value is when we are creating the technology locally, when we are benchmarking with the best across the globe, and all of us will have a clear learning curve, and then we will be able to become clearly self-reliant. I think that is very essential. So that is why I would like to end with our clear perspective that how you think global and act local. I think that is very, very important, that having this approach. So we are proud to be Indians, and we're privileged to be global here. I think that is something which I would like to leave all of you with, and definitely would be open to answer any questions, anything else around it. Since we had paucity of time, so I've just tried to limit and give you a brief insight into my perspective and what clearly I see could be the opportunities which all of us could avail and really work together, because this industry is not about competition. This industry is all about collaboration, and how all of us are collaborating and working together. And that is what is collaboration with co-opetition. So that is a clear perspective for moving forward. So thank you, and I would be open to any questions and interactions as we move forward.
Thank you. Thanks, Mr. Arya. We'll have questions at the end of the session. Thanks for an excellent presentation and answering all the questions posed Now we move on to the perspective of a tier 1, global tier 1 at that. So I invite Mr. Guru Prasad Mudlapur, Regional President and Managing Director, Bosch Automotive Electronics India Private Limited. Since January 2018, he also heads the project house for electrification within Bosch India. He joined Bosch in August 2008 and has held various roles in engineering management. From 2013 to 16, he was Vice President Electronics Engineering, responsible for the entire electronics control unit design and development. So given his background, so Guru Prasad would be the ideal person to tell us about what's happening in the world and in India as far as electrification in the mobility sector is concerned, and what is enabling and what is retarding it. And when do we expect the transitions to happen? What will drive those transitions? And what are the key components and technologies that are involved? What competencies, capabilities are required? So over to you, Mr. Guru Prasad.
Thank you, Sundaresan. I think it's my pleasure to be part of this forum and to share some insights. Let me quickly share my screen and then get going. So if somebody could just say if they see the screen, then that'll help me continue.
Yes, sir.
Okay, thank you. So overall, I think I'll keep it quite brief, have more time during Q&A for further details. But I'll just give a perspective on what is the view of Bosch, how do we see electrification panning out in the years to come, and how has the journey been so far. Bosch is one of the largest tier ones globally. We are a 78 billion euro company with more than 400,000 employees, out of which the good thing is a large part of them, 73,000 employees, are in R&D. And the pride in India is that we are the largest development center outside of Europe for Bosch, and we do a lot of work, not just for India, but for the whole globe out of India. And we take a lot of work also on electromobility and do it out of India. Bosch has four major divisions: mobility, industrial technology, energy, and building solutions, and consumer goods. And mobility solutions, to which I belong, is the largest of it. It's about 48 billion euro in turnover. So now stepping a little bit into how we see the electrification trends. So let's go a little bit deeper into various aspects of what is impacting electrification. Of course, the market. We know so far China has been one of the key electrification markets. But overall, in Europe or in US, the market share of EV is growing considerably. The battery costs are continuing to drop year on year, and that's certainly been a key enabler for growth. It's been a cost-sensitive market overall, but at the same time, in the Western world, at least, the high-end cars sell far more than the smaller EVs that we tend to see in India today. There has also been an increase in charging points all over US. There are several charging networks. These are coming up also in the Europe. And China, of course, has quite a lot of this. Another trend which has been very key is legislation. Overall, emissions have been very, very highly regulated over the years in the West. And CAFE norms are tighter and tighter. And the push to EV in most countries is through specific subsidies, either to take off a combustion vehicle off the road or to incentivize buying an electric vehicle. And now, in terms of how an end consumer sees it, the overall acceptance for EVs has been increasing very, very steadily. EV started off more like a green image kind of a vehicle, but at the same time, people who drove cars like the Tesla started to experience how sporty it can be, how good the acceleration can be right from time zero, and how good the fun factor of the car could be. And of course, all the non-legacy introductions in electric vehicles, for example, how you interface with the vehicle and how you treat the vehicle, how good the user interface is or the infotainment is. These are all very, very critical for adoption. Of course, EV fits currently at least several use cases extremely well. Most people do not have very long commutes, so I believe it's only 5% of the population which does very long commutes on a daily basis. So it's a category which helps electric vehicles very well. The environmental awareness, as I said, is also increasing quite a bit, and this is in countries driven by the government through the NGOs, but people themselves are very, very focused. Of course, OEMs and mobility providers have been key to push for growth in electrification. The colleague just before me had a good overview about that. And technology, of course, is very, very key. And this is an area where there has been a lot of work done over the years. Bosch, in fact, has invested close to 600 million euro year on year for the past 10 or 12 years to build lots of solutions, lots of products and services into the electrification market. The electrification of a car, be it through battery electric vehicles or through hybrids a little bit earlier and moving on as well, has seen a trend from having individual motors, individual components, and those getting integrated into e-axles for efficiency purposes or for cost purposes. Also, what we have seen quite a lot is the move from distributed E architectures to more zone E architectures to vehicle computers in some categories. So this is something that's evolving quite a bit. The voltage platforms, of course, are different. The two-wheelers, three-wheelers have largely been on a 48-volt platform, while passenger cars are at 400 volts mostly, and commercial vehicles and buses are at 800 volts and so on. So this has been a trend, and colleagues earlier talked about silicon carbide. These are all new things that are coming in simply to improve efficiency and push into the market. The competitive landscape in electrification is also a very key trend. The intense competition also in the EV OEM segment, but also in the tier 1 segment, is already pushing costs down very rapidly, is making very good progress with regard to how quick technology can come in, and also specifically in terms of how startups can come and contribute into the electrification area. So this has been a sort of a quick snapshot overview on the trends that we see overall. And now if we look at how powertrain systems largely focused on passenger cars and LCVs look today, there are 4 broad categories we see. Of course, vehicles with combustion engines will continue. That's a no-brainer. So outside of that, there are 4 broad categories, depending on which segment it's applied and how this can be useful. Renewable synthetic fuels are coming in several geographies. I think that's one key area which will continue to progress quite a bit. Hybrids have been efficient. They've done quite a bit of, there has been quite a bit of work done on hybrids, integration together with the IC combustion engines, and that's clearly giving fuel efficiency benefit of between 10 to 15, 18%. So that's something that's going to continue in several geographies and possibly also in India. But the key is the battery electric vehicles, and most people start to associate EVs as battery electric vehicles today. And it's expected that between 20 to 35% of all newly registered vehicles in the world by 2030 will be battery electric vehicles. And they are vehicles which are predominant today as EVs, and that's something which is coming in very, very strongly. We also see in select categories of passenger vehicles, but also largely in LCVs and commercial vehicles, fuel cell vehicles to come in also quite strongly. This is an area which suits low cost, long distance commutes with fuel cell vehicles, hydrogen as the fuel cell, and that's going to be green, clean, and it's well suited for long distance driving, which is what most commercial vehicles do. And that's a very good technology to focus on. And we are glad that also India is catching up this race, and we're doing quite a lot. And the recent budget talked about how India wants to promote hydrogen ecosystem. And we know several companies are active already in this area. So if we look at the overall portfolio of what we offer, and of course, most tier ones offer a similar portfolio. So this chart is possibly not so unique to any tier one, but it gives a spectrum of how we see power classes, voltage classes, and of course, the full range of electrification components going into the different categories of vehicles, starting from e-bikes all the way up to commercial vehicles in very many different power classes, from 0.25 kilowatt all the way up to 450 kilowatt, and different voltage ranges from 36 volts, 48 volts being very popular at lower end, all the way up to 150 400, 500 kilowatt for commercial vehicles, but also at 800 volt there. In terms of solutions for these categories, Bosch does quite a lot of work. We offer solutions for different categories of hybrids, be it motors, 48 volt power packs. We offer e-axles. We offer all sorts of power electronics, DC-DC converters, inverters, and e-axles, of course, in various power classes here. Of course, fuel cell electric vehicles as well. So the entire range of offering is possible from Bosch, and we do that globally today with most OEMs, and we are already in talks with several OEMs in India to bring the entire portfolio into India as well. So to summarize the key takeaways, the electrification market globally is picking up very, very rapidly. It's turning closer into a mass market segment. And the expectation is about 35% of all new vehicles will be battery electric vehicles. In India, of course, it's not yet that dominant. Last year, I think we sold between 3,000 and 4,000 passenger cars, but this is something on an upward trend, and over the next 4 to 5 years, we would see rapid adoption of electrification also in the Indian context. As I said, we offer the entire range of powertrain solutions, all components, and a key thing is electrification requires a whole new set of core competencies, be it in the areas of cost innovation, system integration, standardization, harnessing maximum efficiency, or in terms of building new power or voltage segments. So this is a core competency that needs to be totally rebuilt, and be it in battery or in power electronics. So overall, this is an absolutely essential skill we have to also develop locally, and this is a key area for the automotive industry in general if we want to progress electrification. So I think we offer a complete portfolio and support, and I would stop at this now and be open for Q&A at a later point of time. Thank you.
Thanks, Mr. Guru Prasad. So we now move on to the people behind all these standards and regulations. So I invite Mr. Anand Deshpande, Senior Deputy Director and Head Automotive Electronics Department, and ARAI's Center of Excellence on E-Mobility from ARAI. He is primarily responsible for development and evaluation of automotive electronic embedded systems for EMI, EMC, environmental conditions, performance, etc. He is also responsible for electric vehicle development, testing, evaluation, policy, and standard development. He is a member of SAE, Society of EMC Engineers. And I think he would be the right person to tell us, give us the overview of type approvals applicable for EVs and EV components. What are the performance and localization requirements for availing FAME 2 benefits? So Mr. Arya briefly talked about PMP, so we can learn more about that. And how is ARAI supporting local players in enhancing their capabilities and technologies? Over to you, Mr. Deshpande. Unmute. I think we hear you. You're muted. No, we still can't hear you. I think you are unmuted, but we can't hear you. No, no. I think we will do one thing. We will move on to Mr. Vishwanathan, our next speaker, and then we can come back to Mr. Deshpande. Is that okay with you, Mr. Vishwanathan?
Yes, yes.
Okay, great. So in the interest of time, we will move on to Mr. Vishwanathan, Executive Vice President, TUV NA. He has more than 30 years of experience in design, quality system, and product certification. His key role is making the world safer and bringing excellence in business in the area of testing, inspection, and certification of infrastructure, renewable energy, and railways. So the questions for Mr. Vishwanathan are: what are the quality requirements for EVs, EV components, and ICs? And what are the typical challenges encountered at component level? What are the global best practices to improve quality? And given the context of Industry 4.0 and that it is expected to improve both productivity and quality, what are the opportunities and challenges to realize these benefits? How do we exploit the opportunities and mitigate the challenges? Over to you, Mr. Vishwanathan.
Yes. Good evening, Mr. Sundaresan. Good evening to all panelists and good evening to the participant. I'll share the presentations. Just I'd like to address the challenges and opportunities, especially in quality and productivity with respect to EV components and integrated circuit industries, as advised by Chairperson Sundaresan. What is our role as a TÜV Nord? Is a German multinational company. TÜV India is Indian TÜV Nord company. Our main activity was Saman Seidu Sirtukum Kolpur Amaindoropal Kodame Sandor Kani. This is the role which we are playing is a quality and testing inspection certification body which will work as a balance even during a rest period. It will show which is actually right or wrong. So we are one of the independent impartiality organization which will take care of the quality and testing inspection certification body as briefed by Tirukural 118. The EV sales in India stand at 3.8 lakhs unit in 2019-20, and the EV battery market goes around 5.4 gigawatt during the year. The electric two-wheelers are highest selling in the entire segment for this year. By looking at the potential market, the GAGR 44% between 2020-2027 about the EV market. This is a very high potential and growth market, and it is expected to hit 6.34 million unit annual sales by 2027. So I think the excellent experts are discussing how we can cater into that market of EV vehicle in 2027. Okay, next. The challenges in quality in EV vehicles. So I divided into critical components. For example, battery, which is a short circuit and corrosion, IP protections, which is needed. Then drive and motor insulation failure, overload, and as well as overheating, bearing problem, slip ring and brush failure. And then onboard inverter, which will there is a frequent failure on capacitor wear, over usage, IGBT failure, and temperature failure. And then power cable, especially insulation failure and degradations, and terminals and charge connector reliability and heat dissipation and stress and IP protection. This can be avoided by implementing the best practices, which will being followed globally, especially in European and with China. Whenever there is a component is being developed, so we have to ensure that the process is being well established to meet the particular intended performance. So the supplier has to be evaluated and has to be certified by the International Testing Inspection Certification Body. Then each and every component has to be certified according to the relevant IS, IEC codes or EN standards, whether the component was designed to deliver the expected performance. Then prototype testing and certification ARI is doing. So we can, the growing market like us, we also have a laboratory. India is also having laboratory as well as Pune and Bangalore. We can also support the market to support on the prototype testing as well as certification. Apart from the third-party certifications, mainly on a process side. So how we can improve the process, how we can work on the supplier side as well as customer side to ensure that the process are being in line with the international practice. And ultimately, the government, institute or OEM or supplier has to develop, work together to make research and development, because the EV vehicle market has to have a work on like how the mobile is made a revolution in the Indian industry. So the EV vehicle market has to work on research and development, and especially technology development. It needs continuous improvement on technology, which will improve the life of the product as well as the affordable cost to the consumer. Then where India lacks. So when we are developing an industry, when we have a big potential in the market, we are lagging to identify the raw material now presently, which we are now hanging on the China, which is a mainly battery. So we have to depend upon self-reliant on a production of EV batteries. And availability of ample supply of raw material and limited investment in R&D is a big concern in India that we have to address jointly, all of us together. Especially in electronic industries where chip design and electronic manufacturing, we are doing extremely well. But it is lack of infrastructure and as well as skilled labor in the country, which is addressed by senior people also. Skilled labor is shortage in country, especially electronics. It is purely depending upon the SME and small scale industries where the electronic industries are mainly rely on this. Even though it is creating a lot of employment, we have to go for the labor mode to the automation mode. That we have to look on this. Then there is a government India reduced custom duty in electric vehicles, which will assume that the growth will go, but it pull down the further R&D and the investment in the field of R&D. So now we have a very good, strong initiative by our Honorable Prime Minister on renewable, especially solar. So solar, along with the EV vehicle, the combinations, the entire institutional industry and government can work together to overcome the lagging area. Then challenges, especially in EV and its related components, a short range of run. So when the customer investing or purchasing a vehicle, so he should get a benefit which he presently availing the benefits. So recharging times, which already addressed by Nishant as well as the Bosch team. Then initial cost and charging station availability, which we are addressing on the infrastructures, which we can convert all the petrol bank or facilities to become a charge stations with quick charging facilities with the help of technology improvement. And then battery replacement cost, and even the two-wheeler is high, but the battery replacement is 50% of the vehicles. So really, we have to see that it is R&D put a big role, and where we can make affordable to the end user or consumer to purchase the vehicles. Then there's a different standards, especially in EV sector. Still, globally also, still there is a standard is not like other growing sector like automotive. Especially EV vehicles, still standards are under development. Even Bureau of Indian Standards are being developed, but it is not up to the expectation. For example, battery, there is a standard. So I made a comparative of Indian standard and as well as the international standard. There is a gap. So BSI as well as Quality Council of India, then ARI and like TU India can work together to cover quickly to develop relevant standards and being implemented, which will help the manufacturing industry to follow the quality standards, which will make the product viability to increase the productivity. So some of the connector, terminal cables, charging systems, there is no such now being TEC is being formed, but it's still there is standard has to come how the EV charging station, what is it expected out of that. Then grid communications, there is available in ISO 15118, but we have to convert into that our Indian continental requirement. This is some of the still there is the international standards are being developed. EV vehicle, because we are discussing for last 15-20 years on EV vehicle, but now we crossed a good level, but still there is a effort is needed from the various stakeholder to develop a standards and codes, especially for the EV vehicles. How can quality and productivity can be leveraged to implement Industry 4.4? Now, because the electronics and electrical industries are mainly depending upon the laborers. Now we have to look for the data is available for so many years with us, how we can use the artificial intelligence by using the data to enhance the production capacity and its quality. The model would have been shifted from prediction to prevention of defect to the data analytics toward the artificial intelligence. So that we have to work with the institution as well as the industry experts through R&D. Then we can use the artificial intelligence to improve the productivity as well as quality. Then adoption of the robotics and automation would shorten the production cycles instead of depending upon, even it is going to give the employment, even if you're not using the automation robotic, but by looking the volume of business available, by looking India can be a global hub for the EV vehicles. So it is very important. We have to look for the robotic and automations to reduce the time to market and bring the inefficient realization of the resources for the market. Then connectivity of machine to the people and machine to the machine would tighten supply chain. We have to reduce the supply chain and reduce the lead time also to see that the product is available for the market. Then skill development, as I briefly briefed. So we have to move from the physical world to cyber world. So wherever possible, then now we have an excellent institutions are available from the IIT, then ITI, then engineering colleges. All the students can be trained with the help of like big industries with combination of the skill, unskilled to skilled labor by using the technology like self-learning robotics, self-optimization of the system, interconnection with the external parties, augmented reality, industrial big data. So the big data, industrial data has to be used to improve the skill development and virtual work preparations. So then we can avoid the error, especially electronic, because even some small error on the electronic, it will have impact on the safety of the product and life of the product. So we have to try to avoid involvement of laborers. Instead of that, we have to go for the robotic. Then we have to go for the automation by using artificial intelligent data. So we have to go for the technology-based solutions than the physical world solutions. Then how can partner? This is very good. Now instead of there are two I address. One is a material supply, another is a technology sharing. Then like international company, there is a lot of fast charging technology companies are available. Then battery technology, manufacturing technology, and artificial intelligence, machine learning. Then as a group, like small industries can join together. Then they can form a bigger company, collaboration or cooperation. Then they can form a partnership or joint venture, which will help the product quickly to develop the product, which can complement each other's strengths so that we can support the industry with respect to price as well as the productivity. Then material supply also, then we have to work, we have to use that big player, and we have to take the help of material supplier. Then we can develop battery with the help of R&D like IIT, IIM, which will meet the international expertise we can support on this. Then top three priority which realize the e-vehicle sector. So the one is set up an Indian mobility R&D protocol, which is now affordable by the bigger company as well as the IIT institution. But we have to, each state should have the R&D facilities, and all R&D facilities has to work under ARI so that the benefit can be achieved quickly. And then pan-India supply chain network. So this is also reduce the cost of that, and the testing certification of the e-vehicles and its component as quick as possible, which can avoid the delay of the product development. Then opportunities in India. So with a global growth rate of 60% EV vehicles, India has the opportunities to become a global player in this space, especially in the battery and cell as well as IC manufacturing, and which is contributing to the EV vehicles. Then public transport and fleet operator have a greatest opportunities where they can support the SME and as well as institutions, so that the vehicle can develop and run longest as well as commit more number of people, so which will help to reduce the emissions. So then support expected from the government. So research R&D development, especially for battery science in cooperation with the international institution as well as IIT, IIM. Then institutional support for the development of skills, EV vehicles and IC. Then testing facilities, which will improve the EV vehicle and its complete components. Now it's being developed by ARI, but may not be sufficient when we want to grow 60% market. Then support to form a technical committee to improve the Indian standard to meet the global quality. So this can be done at a faster rate, so that we can ensure that quality is being developed in initial stage itself. And new policy and budget to promote e-vehicle usage as well as a developable market. So we have to attract the consumer. Unless the consumer will not purchase the vehicle, if the e-vehicle is cost effective as well as benefit to the user. So that we have to promote how the e-vehicle is benefit with respect to global, with respect to individual, with respect to buyer. So that we have to do that. That's all from my side. Any questions, then I'll be able to answer. Otherwise, we can answer on the.
Thank you, Mr. Vishwanathan. Let's now go back to Mr. Deshpande, and let's see if we can hear him now. Mr. Deshpande.
Hello. Hello, am I audible?
Yes, you are.
Now it's okay.
Oh, thank you, great. Sorry for the maybe some network problem. So sure. Now I will make a brief presentation from on this subject. So let me share my presentation. Is my presentation visible?
Yes, it is.
Okay. So good evening, everybody. I will be mostly talking on electric vehicle components, the standardization in India, the type approval requirements, FAME scheme, what are the requirements, government policies, and testing of electric vehicle components. So I will talk about briefly about electric vehicle standardization in India. As my predecessor speaker, Dr. Vishwanathan, was talking about the need of standards, Indian standards in line with global standards. So I would like to mention over here that in India, we have got very robust type approval system, and electric vehicle standards are in place for last 2 decades, and those are continuously updated in line with international standards and regulations. So in India, the automotive segment is regulated by Central Motor Vehicle Rules, that is called CMVR, and these rules come under Motor Vehicle Act of 1988. So Ministry of Road Transport and Highways is the nodal ministry which mandates Central Motor Vehicle Rules, and under Central Motor Vehicle Rules, the standards for automobiles are notified. So for electric vehicles also, there are standards in place, and those are in line with UN regulations or global technical regulations, which India also takes part in international discussions and deliberations on standard formulation. We give our inputs and our comments, and the globally accepted standards are adopted in our country, and our Indian standards are also formulated. So typically the type approval of electric vehicle includes various broadly 3 areas: verification requirements, safety requirements, and performance requirements. So since it carries onboard electricity, there are requirements for electrical shock, then water because of rain or washing, there could be water seepage, so water effects tests are carried out. Battery safety, RESS is nothing but battery, regenerative electric energy storage system. So battery safety is also important. Crash of vehicle in case of an accident, what will happen to the electrical system, to the battery. Then various lighting system on dashboard symbols. Then electromagnetic compatibility, because it has got a lot of power electronics. And also there are performance requirements like range, how much distance the vehicle will travel in one charge, electrical energy consumption, which is equivalent to fuel consumption of IC engine vehicle. Then power capacity of the vehicle, which is nothing but the motor power. Gradability, how much gradient the vehicle can climb, what is the maximum speed, acceleration, performance. Braking is very important. So braking performance, here actually because of regenerative braking, the braking performance of electric vehicle is improved. So these are broadly some of the requirements for the type approval testing. And these are the tests which are carried out on the vehicle, and some of the tests are carried out on the components. So these are the standards in India which are notified under CMVR. So for electric vehicles, there are standards, set of standards. Then for hybrid electric vehicles, then there are standards for retrofitment kits like LPG or CNG kit. We can have electric kit which can be fitted into IC engine vehicle. So for retrofitment kits, then for charging stations, we have got standards. Then small series, if there are a small number of electric vehicles which are being introduced, then there are low speed two-wheelers. There are some requirements for e-rickshaw and e-cars. There are specific requirements notified under CMVR, and there is a dedicated standard on battery safety. So these are all standards which are in line with international standards, and those are notified under CMVR, and those are continuously updated in line with the global trends. So these are in the brief about the standards. AS 038, the current mandated revision is revision 1. It talks about construction and functional safety, electrical safety of the electric vehicle in line with UN regulation 100. Then AS 39, it talks about measurement of electric energy consumption in watt hour per kilometer. That means how much electricity is used for running the vehicle for 1 kilometer. This is equivalent to kilometers per liter of an IC engine vehicle. In line with regulation 101. Then AS 40, it does the measurement of range in line with regulation 101. Then measurement of motor power in line with regulation 85. Then AS49, it talks about various CMVR rules, how those are applicable for electric vehicle, how the gradability test will be performed, how the brake test will be performed, how the pass-by noise test will be performed, how EMC test will be performed. So this is a mother standard. Then AS48 is the standard which talks about safety requirements for batteries. This standard is formulated based on USABC requirements or ISO IC standards. Now we have got the roadmap. These standards are getting updated in line with global standards. For example, there is a global technical regulation number 20, which is getting formulated at United Nations, where all the countries like USA, Europe, Japan, Korea, China, India, all participate. And this GTR 20 is formulated. Phase 1 of GTR is already published. So in line with that, now the practice is electrical safety of vehicle and batteries combined together. So AS38 is getting revised to revision 2, which talks about electrical vehicle and battery safety combined together. So this standard is already formulated and it will be implemented in maybe next 1 or 2 years. Then there is a separate standard. This AS38 revision 2 will be applicable for passenger cars and commercial vehicles. And there is a dedicated standard has been developed, AS156, for two-wheelers and three-wheelers vehicles. This is in alignment with UN Regulation 136. Then this standard is also really published, and also it will be it is in the pipeline for the implementation. Then EMC standard is getting updated for electric vehicles. Currently AS004 Part 3 is in force. This is common for IC engine vehicles and electric vehicles, but revision 1 is formulated considering specific requirements for electric vehicles for the EMC, which stipulates the requirements for onboard charger as well as electric vehicle during charging. So this is in line with UN regulation number 10, 5th revision. So this standard is also published and it is also in the pipeline for the implementation. Similarly, there is a separate standard recently formulated, AS168, which is for electric agricultural tractors. Now, a lot of tractor companies are also coming up with tractor products, agricultural tractor products with electric powertrain. So this standard has been specifically formulated for the electric powertrain of electric agricultural tractors. So these are the standards in addition to the presently notified standards, which are in the pipeline in next couple of years, those will be implemented. But at the moment, under the transitory provisions, if any company is ready to meet the advanced standard, they are welcome. So they can get the compliance as per the advanced standard and they can introduce their products. So that provision as a transitory provision has been made in the standard. Then coming to the hybrid electric vehicles, there is a standard AS102. In hybrid electric vehicle, there is the engine also and there is electric motor also. So there is a separate standard for hybrid electric vehicles based on UN regulations. Then this is an India-specific standard for the retrofitment kits, because in India we have got very popular CNG kits fitted into the IC engine vehicles. Similarly, there are companies who are bringing electric kits for converting IC engine vehicles into electric vehicles. So this AS123 standard has been specifically formulated to approve such electric kits. And there is no international standard reference. This is the India-specific standard. Then coming to the charging stations, there are two types of charging which is possible for the conductive charging, AC conductive charging or DC conductive charging. Ministry of Power has issued guidelines for the charging connectors, couplers, and communication protocol for the charging stations. For example, for low power charging, there are Bharat EV charger standard AC001, and for DC charging, it is Bharat DC001. It is shortly called as BEVC, AC001, BEVC, DC001. And the connector for AC charging is industrial socket IC60309. And for DC charging, it is GBT connector with CAN-based communication protocol. and that is the India-specific protocol. For high power charging, our government has aligned with the international practice. For AC charging, it is type 2 connector as per IC 62196-2. And for DC power charging, both options of CCS, that is combined charging system, or CHAdeMO, as depicted in IC 61851 standards, has been accepted by the government. So this is overall the architecture for the public charging stations. And as Dr. Vishwanathan was mentioning, there is already a BIS committee working on making the Indian standards based on the relevant IEC standards. So IS 17017 series of standards is in formulation. Some of the standards are already published. So the standard, basic standard for the general requirements for conductive charging, IS 17017-1 has been already published. Then EMC standards -21-22 have been published. Communication protocol standards -23 and -24 are in the final stage. Similarly, we are also making standards, because in India, we have to understand that a lot of vehicles are two-wheelers and three-wheelers. Majority of vehicles are two-wheelers and three-wheelers. So India-specific standards for a very affordable AC charge point, which will provide a simple AC charge point with metering, energy metering, and Bluetooth protocol. Such standard is being developed for AC charging, and for DC charging of two-wheelers and three-wheelers on the similar lines of CCS. A combined solution for AC and DC charging is also innovative solution is being worked out. And first, the prototyping is in because there is no international standard for this. So prototyping is being done, and based on that, the standard also is in the making. So by next 6 months, we will have complete IS 17017 series of standards which will be available. Parallelly, work is also ongoing for the swappable battery standards, and also for the standards for high voltage, high power charging for the buses. So on the charging front, a lot of standards are in the pipeline, and those are getting formulated. Then coming to the government policy, Government of India has launched National Electric Mobility Mission Plan, that is called NMMP, and under that government has launched FAME India scheme, that is faster adoption and manufacturing of electric and hybrid vehicles in India. And currently the phase 2 of FAME India scheme is in progress from April 2019. This scheme is for 3 years up to March 2022, and rupees 10,000 crores have been allocated under the scheme. Under this scheme, the main objective is to create demand creation so that the consumers are encouraged to buy electric vehicles. Incentive is based on battery capacity. There are performance and efficiency criteria for eligibility. Focus is on localization. All commercial vehicles like taxis, buses, auto rickshaws are incentivized, except even personal two-wheelers also can be incentivized, considering that large population of vehicles in our country is two-wheelers. Then for buses, there is an OPEX model, and charging infrastructure also rupees 1,000 crore have been allocated. So these are the performance and efficiency criteria notified under FAME India scheme phase 2. So if you consider different categories of vehicles which are identified for getting incentive under FAME India scheme phase 2, like electric two-wheeler, electric three-wheeler, e-rickshaw, e-cart, electric three-wheeler auto rickshaw, four-wheeler passenger car, small car, four-wheeler passenger car, big car. Sorry, the fifth item is length is more than 4 meters. Then electric four-wheeler goods vehicle, electric bus 9 meter, and electric bus 9 meter to 12 meters. So these are the categories which will get incentive, and there are performance and efficiency criteria. For example, what should be the minimum range of this vehicle? What should be the maximum electric energy consumption? So vehicle architecture should be efficient so that electrical energy consumption is below a certain limit in kilowatt hour per 100 kilometer. Then the vehicle should have minimum maximum speed. It should not be a low speed vehicle. It should have a decent maximum speed. And also it should have proper acceleration so that it will have pickup. It can climb the gradient. In the city, it can climb the flyover, or any kind of a gradient which is typically available on the city roads or on the rural side. So that kind of acceleration it should have. So these are the various limits which have been prescribed under FAME scheme for these categories of vehicles. And to qualify for the FAME incentive, these are the criteria the vehicle model has to meet. The basic criteria is that the vehicle model should have type approval as per CMVR. So as per the standards which I explained, all the standard compliance it should have so that it is type approved as per CMVR. The vehicle should have advanced battery. The advanced battery definition in the FAME scheme is that specific density of the battery chemistry should be at least 70 watt-hour per kg, and it should have minimum cycle life of 1000 cycles. Then the vehicle should have electrical regenerative braking system. Then it should meet the performance and efficiency criteria as per this table. And it should meet the localization requirement as per the phase manufacturing program prescribed by the government. In the next slide, I will come to the phase manufacturing program. And the vehicle along with battery should have minimum 3 years warranty. So these are the eligibility criteria. So the designer of the vehicle has to consider these criteria and these performance criteria and also the warranty requirements while designing the vehicles, while designing the components of the electric powertrain. So these are the kind of design parameters inputs for designing the electric vehicle category or electric vehicle model. This is the phase manufacturing program which is prescribed under the FAME India scheme. So there are almost all critical EV components, 21 components have been identified and the dates have been prescribed. For example, now currently we are in the midst of this implementation of this phase manufacturing program. So this phase manufacturing program started from 1st April 2019 and it is going up to 1st April 2021. And currently we have completed implementation of 1st October 2019 and 1st October 2020, and we are into 1st April 2021. So all the manufacturers have to initially they can start with the imported component, but subsequently by these dates they have to localize the components. That is the main objective. Now coming to ARA, Automotive Research Association of India, we are based in Pune. We are autonomous institute affiliated to Ministry of Heavy Industry and Public Enterprises, Government of India. This ministry actually is the parent ministry for the auto sector. And we have got 3 locations in Pune, and in Chakan we have got a Center of Excellence on Electric Mobility, where we have got comprehensive test facilities for the design, development, testing and certification of electric vehicles. We support the industry, auto industry, startup companies, MSME companies in the design, development and testing of powertrain, chassis, safety, components and performance evaluation of electric vehicles. These are some of the facilities like motor test bed, battery test systems, battery cyclers, then high voltage supplies, charger test systems. So we have got all the facilities for testing of electric vehicles and their components. For electric vehicle components, we provide support to the industry in reliability, durability testing, efficiency testing, safety and performance. For example, electric motors, then energy storage, that is batteries, charging stations and the power electronics. We carry out all the test plans for the validation, calibration of their components and also their prototype vehicles. And finally, once the prototypes are ready, we test them for the compliance requirements for the mandatory certification. So this is in short about the overview about the regulatory framework in India for the electric vehicles and their components, government policies, FAME India scheme, and at ARA, how we are supporting the industry at our Center of Excellence for testing, development, and certification of electric vehicles. Thank you very much.
Thank you for that very presentation. I'm sure all the standards and processes will come in handy. Now we move on to the last panelist, Dr. Rushain Chahal, founder, Tramhoft Schofferlord Private Limited. I hope I'm pronouncing the name correctly. He has rich industry and education experience in project, digital business, product transformation, and innovation. He has worked in 6 countries with companies like Accenture, Blackwater Research, GE Appliances, GE Aircraft, and so on. He has been an entrepreneur with, he has multi-billion-dollar startups in e-commerce and technology. He has a number of patents, about 99 filed and 84 granted till date. So with his background, I guess the questions for him are obvious. So what should India do to increase the pace of electrification and adoption of EVs? And what are the kind of partnerships Indian organizations can forge with global organizations? So Dr. Chahal. Hello. Hello, we cannot hear you, Dr. Chahal. Looks like there is a technical problem.
Sir,
And
I'll
we are
try to
also
connect him. Just allow me 5 minutes.
So by then you can take a few questions by.
sure. So there is one question on fuel cell EVs. So what are the prospects of fuel cell EVs in India? Can one of the panelists answer? Okay, let
Can
me.
I take?
Yes.
Yeah. Actually, government is encouraging all types of clean fuels. For example, in this budget, government has launched a hydrogen mission. So government is also focusing as a long-term strategy towards hydrogen fuel cells. But currently, hydrogen fuel cell actually is also an electric vehicle. It only replaces the hydrogen fuel cell, the battery with hydrogen fuel cell. The rest of the electric powertrain is same. But currently, the technology of hydrogen fuel cell is quite in advanced stage of research, and it is practically available, commercially also available. The only concern is cost of the hydrogen fuel cell is very high as compared to the batteries. So maybe short to medium term battery electric vehicle is the solution, but as a long term strategy, hydrogen fuel cell could be the potential solution for the electrification.
Thank you. Dr. Bala?
Yeah, we analyzed this problem in the hydrogen enclave. So what we found was we need to develop specific routes for buses, let's say, for example, where hydrogen is available from the fertilizer plants and chloroalkali cell plant. It is a byproduct, and in some of them they are flaring it. It's about 10% of the hydrogen produced is flared. And so if some of those points of plants are nearby and the highways are nearby, we should be able to do it. There is another technology that has to come along with the EV technology, and it has nothing to do with EV technology. And that is a carbon-carbon canister, which has to be 700 bar pressure capacity. So the manufacturing ecosystem for the cylinders, the carbon-carbon cylinders, is very key. Otherwise, the cost of transportation, energy cost of transportation of hydrogen is 2 times the calorific value of hydrogen. So you don't win. Right? So this is what it is. So we need very clever solutions. So I'll give you one solution that North England used was that they used there was a lot of wind energy available in that region about 400 kilometers. So they had windmills that are kept in various 100-kilometer locations, and that was used in a cell, alkaline cell plant, which will produce hydrogen, which is the way we produce hydrogen from water. So they use windmill, produce electricity, produce hydrogen. So there are already 2 thermodynamic conversions. So what happens? So that was giving the hydrogen there where there were no chloroalkali or any other plant. So these are the 2 solutions which has to come. So one, hydrogen production, and 2, canisters, which are core technologies that has to come for fuel cell based, hydrogen fuel cell based systems to happen.
Thank you. Is Dr. Chahal available? Okay, let me ask one more question then, and I think it is probably time to summarize. We are running out of time. The talks have been so interesting that yeah, I didn't really bother about calling time on anybody. So the next question is on battery cell technology. Where does India stand now, and what should we do to better battery density capacity manufacturing? I'm not sure what they mean. Maybe higher density batteries. How do we manufacture? Again, any of the panelists or Dr. Bala?
Yeah, there are 3 things that are happening in the world. One is, whether we can go towards metal air and lithium sulfur batteries. By metal air, we mean lithium air battery. They're about 5 to 10 years away, but lithium sulfur is suffering from few other problems which are being solved. But it's not going to be that easy. See, at least they say 5 years minimum before we could see. This is the energy density wise which we can increase. But really what is happening is that in our existing NMCs itself, the amount of what we call as milliampere hour per gram, which is the metric that is used to understand the developments in this, they find that it is 2 things are to be simultaneously solved. One, they want fast charging, and 2, they want charging capacity. So if when they went to certain uniform sizes and etc. of particles to 10 nanometers, etc., some groups have shown good performance, etc. But how it translates in scalability? You can do many great things in lab, but when you go and scale it up into a process, into manufacture, things don't play out and pan out that way. So one of the problems that is being attacked is that we need to attack the chemistry, which is this part. Then we need to attack the manufacture, which is the other part. The manufacture for a long time is based on generation 1, generation 2 technology lines, which are based on organic slurry-based systems for depositing, or what we call as Dr. Blade process of putting the slurry of anode and cathode carbons, cathode active materials on a copper and aluminum strip. So this is the technology that has been there for a long time. And now the changes are twofold. One fold is going from organics to aqueous, water, so that the whole cost of the plant, which is taking out the organic solvents and putting it, recirculating it, which is carcinogenic, it occupies 50% of the cost of the plant. The second thing is to go towards metal air batteries and dry systems, which are solid state batteries. So which is where probably the breakthroughs will come. One is it is directly metal, lithium, and the other thing is that it's a solid electrolyte, so it's very safe. And the technologies are entering now what we call as technology readiness level 6, 7, pre-production, pre-commercial levels they have reached. So my bet will be 2 things. One, all these old organic based solutions in the manufacture will find an exit.
Get back
You should know.
up there. Yeah, I think so. Yeah, I'm doing that. Yeah. Hello. Hello, am I audible? I just had some blackout on my laptop.
Yes, sir, you're audible.
Yes, sir.
Okay, thanks. Just in time.
So I think Nishant sir wants to speak something. Is he there?
Yes.
Yeah.
Am I audible?
Yes, sir.
Yeah. So, no, basically, just to share that on the battery front, clearly what we are seeing as the energy density is going up, and there are multiple thermal management systems as well as the cell chemistries which are applicable specific to the vehicle segment. So, in general, if we are seeing for two-wheeler, three-wheelers, buses, I think whether it is LFP or NMC or other chemistries, depending on the packaging, I think it is important to understand that whether we are building these batteries only for the first life or keeping the second life in mind. So that is a very important perspective, because most of the batteries which are being built today are being built from the first life, and then whatever is left is for the second life, where the second life can't be valued enough. Whereas if we are able to bring in a first life and a second life perspective and look at a 15 to 20-year horizon for a battery's lifetime, and the first life being about 5 to 7 years maximum, and second life going up to about 8 to 10 years. So that can resolve the problem of battery recycling and also really boost the energy storage market, and will become very cost effective for energy storage as well. So that kind of life cycle planning, I think, is very essential in this case. And because we have majority of the country has high temperature, so how we are able to protect the battery life, whether with cooling or with regenerative braking and optimizing the battery size to the maximum extent possible, I think that is very crucial. So that is something which we should take up.
Thanks. Yeah. I think with that, we come to an end. Dr. Chahal is not available. So just to summarize the entire panel, I think we covered good ground. We went over the customer requirements, we covered the ecosystem requirements, then we covered what are the global trends and what kind of technologies are having a role, or rather they are directing the evolution of electrification of the mobility. And then we went over the various standards that are applicable both at global level and at India level, not just for electric vehicles, but also for the electronics, and how Industry 4.0 can help improve the quality and the productivity of electronics manufacture. As far as the points that I wanted to add, they pretty much were covered in one presentation or the other. It's just going to be a repeat if I am to go over them. And also, given that we have actually exceeded the time, I would like to thank all the panelists for the excellent insights they brought, and giving perspectives, different perspectives, and providing the overview of how electrification is going to progress in India and what should be done in order to either speed it up or do it better. Thank you. Thanks, everyone. And I thank QCI and the organizers for allowing me to moderate this session. Thanks.
Thank you, sir. This indeed has been an enriching Manthan, which has touched upon the various aspects in EV component and IC industry. There have been several deep insights and recommendations in today's Manthan that will be compiled into a compendium that would help to strengthen the EV components and IC industry in the country, and will significantly contribute to our Prime Minister's vision of Atmanirbhar Bharat. On behalf of DPIIT and QCI, I would now like to conclude today's session by thanking Shri Prashant Kumarji for setting up the context for today's Manthan, Dr. Bala Subramanian for his address. I also want to thank our moderator, Mr. Sundaresan, and our esteemed speakers for such a meaningful deliberations today. Thank you, sir. Our sincere thanks to DPIIT for their support and guidance. Thanks to all our partners and QCI team for their hard work. And last but not the least, our wonderful audience. Thank you all. We're signing off. Namaste.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you,
sir.
everyone.
Thank you,
Yeah.
Guru Prasad sir. Thank you, Bala Subramaniam sir. Thank you,
Thank you.
Nishant sir.
Thank you, everyone.
Thank you, Sundaresan sir.
Thank you.
Thank you, Anand sir.